It's very, very similar to the test. On the test, I'm going to make you graph two exponentials, similar to the ones that are right here. Um, I'm not going to make you graph the parent. I'm going to ask you for the exponentials to give me the equation of the horizontal asymptote. The horizontal asymptote on this one is 0, and the horizontal asymptote on this one is -3. And when I say -3, I mean the equation y equals -3, or here the equation for the asymptote would be y equals 0. I'm going to give you an XY chart. I'm going to ask you for 3 points. The points I would use for this one over here, this exponential, would be like 4, 5, and 6. This x minus 4 is a shift. This 1/3 means it's going to decay, which is the general shape of the blue graph. And then the minus sign is going to flip it. So instead of being up, it's going to be down. Again, you don't have to worry about graphing the parent, just graph it. You can graph these on to check your answers if you want to practice. You can check them on your graphing calculator or Desmos. Again, these are definitely on the non-calculator part tomorrow. Remember this E, it's just an irrational number. It's just 2.7. It's no different. It's going to be growth in this case, and it's just shifted down by 3. And so it just looks like the normal one, the blue dotted one is the parent, and then it's just shifted down to be the red. On this one, I would plot x equals 0, 1, and 2. X equals 0 is easy because e to the 0 is 1. 1 minus 3 is -2, which is why it's plotted here. And then remember, e to the first is like 2.7, and then 2.7 squared, you can just approximate it as whatever, 7. I don't even care. It doesn't matter at all. It's somewhere in that range. And again, you'll be able to do that. I am going to ask you for the equation of the asymptote and the domain and the range, and then I'm going to do the same thing with logarithms. There's going to be 2 logarithms on the test. You should be comfortable whether the base is like 4 or 5 or 3 or 2 or 10, or if the base is e, then we just call it the natural log. It's just like a logarithm. I'm not going to make you graph the parent. I'm going to give you an XY chart. And again, for this particular one right here, you know that logarithm base 4 of 1 is 0, log 4 of 4 is 1, and log 4 of 16 is 2. So the values you should use are the x values that make the argument 1, 4, and 16. In this case, if this is an x plus 5, you should use -4, which will make it 1. -4, which will make it 1. -1, that'll make it 4. And then I would use 11, and then that will make it 16. Those will be the points you can use because those are the ones you can do in your head without a calculator. And then again, do the domain and the range. Logarithms have domain restrictions, and the range is always everything, where exponentials never have domain restrictions. You can see they're both -infinity to infinity, but they do always have range restrictions because they either start from top and go down, or they start from down and go up top. Most of the standard exponential, like over here, just goes from 0 to infinity, and so this -3 shifted it down. Growth and decay. Again, this is clearly decay. This multiplying by 3/5 over and over again to make you smaller. This is multiplying by g. That would be growth. Don't worry about that negative sign. This is a trick because this is 3/8 to the negative, so that really is 8/3 to the x, which would then be growth. These are all on the test. These are simplifying exponentials with ease. Very similar. All of these are also on the test. You have to evaluate these expressions without a calculator. 81 is 3 to what power? 4. 7 is 7 to what power? 1. 1 is 2 to what power? 0, right? Logarithm of 1 is always 0. When the base and the argument match, it's always 1 because of that fact. 1/8 is 64 to what power? Okay, it's going to go down, and it's going to be flipped, so it's going to be a -1/2. This one's probably the trickiest one. Just think it through. The square root of 64 is 8, but it's in the denominator, so we got to make it a negative, and we got to make it a half. And you can go through all of these. All of these are on the test using logarithms, right? You want to there's a variety of ways you can do this one. You could bring that 3x down and know this is log base 2 of 8 is 3, and then 3 times 3x is 9x. You could write that as 2 cubed, and so then you get 2 to the 9x, and you get 9x. The natural log and e are inverse functions of each other, so they cancel just like 3 to the log base 3 cancel. Those are definitely properties. Finding the inverse of a logarithm, you're going to exponentiate. Finding the inverse of a exponential, you are going to apply logarithms. You can apply regular log, you can apply log base 4, you can apply natural log. So this is not actually a unique answer. I would accept lots of things. You do not have to apply log base 4. On this one, I could see why log base 4 makes sense to apply to both sides, but if you want to apply natural log, that's totally fine. Your answer is just going to look a little different than that. Maybe a little messier in this case, but you can always just apply natural log if you want. Here, you're clearly going to exponentiate and put both sides to the fifth. Calculator part. So this isn't really a calculator part. This is just rewriting using properties of logs. You have to know 5 and 4, so you can split up 20 to make it 5 times 4, which is the addition of logarithms. This is 5 log 5 minus log 16, but then log 16 is really log 4 plus log 4. So you can split that up. This is log 1 minus log 5. Log 1 is 0, and then log 5 is given. And then you're going to have a whole page at the back, which will be solving exponentials and solving logarithms. You'll probably have 2 or 3 of each. Solving exponentials, which is A and D. You are going to use logarithms, and other than D is actually one where you're going to write the bases as the same. So 4 and 8 are going to get along really nice. 4 is 2 squared, 8 is 2 cubed. So you can rewrite those as the same base and then just compare powers. But solving like this one, you're going to add 5, divide by 3, and then apply logarithms. Okay? And I'm going to say you don't even need decimals. Like the final answer here should be natural log of 5 minus 1. Here you're going to exponentiate, or just make it turn it into an exponential by raising both sides of the 5, and then solve. Here you got to make these logarithms 1 logarithm, so you're going to multiply the arguments, then you're going to turn it to an exponential, and then when you solve, make sure you check. When you plug in -8 here, it would make this a negative. Oh, that little x right there, a negative, and you cannot take the logarithm of a negative, so that is going to be extraneous. So you have to check your answers on these logarithms to make sure that they work. And then you're going to have a couple story problems, right? Quarterly, continuously, you're going to use the number E. Quarterly, you're going to divide by 4 and then use monthly payments. Monthly would be 12, semi-annually would be 2, things like that. And then you're going to have some story problems where you're using it. And I'm going to ask you to set up the equation, which means this top purple line I'm going to look for, and then I want the answer. Okay? Certainly expand and condense logarithms are on there, the change of base formula, things like that. But I think this practice test really does do a good job of going over all the options. But you take this and you combine it with the 6.1 to 6.7 and the 6.5 to 6.7 review, and you should be set. Okay? It's 2 pages. The first page is the calculator, or the non-calculator one, where it's just a front and back, and then there's another front and back where I'll let you use your calculator. Okay?